We're going to take a look at something called the Hinge Theorem today. This is our final topic in this triangles unit that we've been studying for quite some time. The Hinge Theorem is very, very closely related to the theorems that we had with inequalities in a triangle, where you found in one triangle the longest side is opposite the biggest angle and the smallest side is opposite the smallest angle. In the Hinge Theorem, we're actually looking at two separate triangles. So let me read it to you. And while I'm reading it, take a look at the three triangles that I have drawn. The acute triangle, the right triangle, and the obtuse triangle. If two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent. All right, we're going to stop right there. That's the hypothesis. If you look at all three triangles that I have drawn, all three of them have one side that's marked with 3 hash marks. All three have one side marked with a single hash mark. So there are your two sides of one triangle, actually congruent to two other triangles, but if you compare them two at a time. The included angle is the angle that's between the two sides. So that would be angle J, angle G, and angle JH. And I have those triangles arranged so that we have an acute angle in the first triangle, a right angle in the second triangle, and an obtuse included angle in the third triangle. Okay, the conclusion of the Hinge Theorem says if you have two sides of one triangle congruent to two sides of another, and the angles between those two sides are not the same measure, then the longer side is opposite the larger included angle. And if you'll compare those three triangles, the last one with the obtuse angle, side H is bigger than G or J, and G and J both have angles across them that are smaller than the obtuse angle, and then the right angle is larger than an acute angle, so G, that length, is longer than J. So hopefully the pictures I've drawn have made this theorem very obvious to you. We're not going to use it a lot, though I will tell you that this shows up on the ACT exam. At least one question, or usually one question. I shouldn't say at least, usually one question. All right, so we're given two triangles in example 1. You have two sides, a side of each triangle, length 10, and a side in each triangle, length of 12, and the measurement for the angle between those two sides is given. One of them is 85, the other angle is 95, and we're asked to compare the sides across from those angles. So according to the Hinge Theorem, the side across from the smallest angle will be the shortest side. So the smallest angle is the 85, so across from it is AB. So I'm going to write AB without the bar above it. That means the length. And that is less than the side across from the 95-degree angle, so that would be side DE. So AB is less than DE. Or if you like to use the greater than symbol, you could put DE is greater than AB. And that's all there is to it, folks. Let's try another one. Another example. And I'll leave the first one where you can see it. This time we're asked to compare GH and JL. We have a side in each triangle marked with a single hash mark, a side in each triangle marked with a double hash mark, and the angles in between are given. So the side across from the 48, HG, or GH, is smaller than the side across from the 51, so that would be JL, because 48 is less than 51. Okay, my guess is that seems pretty clear to you, so let's make it look a little messier. This time I've got one drawing, 3 triangles in it, and you're asked to order side AB, BC, and CD in order from least to greatest. And remember, the diagrams are not necessarily drawn to scale. All right, in all 3 triangles, there is a triangle with a single hash mark. AE is one, or a side, EC is 1, and EC is in 2 different triangles. And then in each triangle, there is a side marked with the double hash marks, ED, and then EB is in 2 triangles. And the included angles are given all except for the one in the middle. So we need to find the measurement of this single angle that's in the middle, because that is an included angle. Since all 3 together make a straight line, if we add the 58 and 56 together, that's 114, and subtract that amount from 180, which is the number of degrees in a straight line, we will find out that that angle up there is 66 degrees. So now we can put them in order from least to greatest. The smallest angle is the 56, so the side across from that, CD, is our smallest side. They didn't ask us to compare them, they just said put them in order, so I'm just going to make the list of the segments. Above a 56, the next would be a 58, so the side across from that is AB. And then finally, the side across from the 66 degree angle is the BC. So 3 angles, least, or 3 sides, least to greatest. Now, if you were in class, you'll know that there were 3 problems on a worksheet that I gave you. If you weren't in class, I've posted the worksheet, but I also have them drawn down here, so we could just do them together. I had the kids do these on their own, and then we answered them and compared to make sure they had them correct. We did not turn this in, so let's just go ahead and work on it. Try to stay ahead of me as I do this, okay? So you look at the diagrams in number 1, you find the single hash marks, the double hash marks, and the angles in between. Decide which angle is smallest and write down the length of the side across from that smaller angle. If you need to, stop the video and then turn it back on. All right, so 58 is the smaller one, so EF is across from that. 60 is the larger, so BC is the larger. Again, stop the video so that you can answer the next one on your own and then start it back up. The included angles on this one are 34 and 35. 34 is smaller, so NP is the smaller. Oops, I don't need that bar above there. So NP is less than LN. If you'd rather see these with the greater symbol, greater than symbol, you could write BC is greater than EF and LN is greater than NP. All right, and the very last one was quite a bit trickier. Again, you're going to need to do some looking. I will describe it to you. We have 2 sides and 2 triangles given lengths of 2. 2 sides are 6. And this time, instead of comparing the angle or the sides, you're asked to compare the angles. So I'm asking you to use the Hinge theorem. Actually, it would be its converse. Those 2 angles that I have marked are included angles. Look at the sides across from them. Sides across them would be LN and KJ, and use the lengths of those sides to decide which angle is smaller. Again, stop the video so that you can answer. Hopefully you notice that KJ is the shorter. KJ is less than LN. So that means that the angle across from KJ, oh, not KJ, I wrote down the wrong one, hold on. LJ. LJ is shorter than LN. So the angle across from LJ, which is angle K, is less than the angle across from LN, which is angle M. All right, hopefully that's enough to make the hinge theorem make some sense to you. I'm not going to give you a big assignment over this. You can just review this one a little bit. There will be one question on your unit test about the hinge theorem, but I will tell you it's more like these first two examples.